Well, let's go ahead and get started. I want to welcome everyone, regardless of where you're joining us from. My name is Melissa Russell, and I'm going to be your host and moderator for today's webinar, API Security for Fintech, Top Solutions and Challenges. I'm joined here today by Stepan Ilyin, who's the co-founder of WallArm, and Alex Diaz, who is our VP of Security Solutions. Before I jump over and hand it over to them, I wanted to let everyone know we are recording the webinar, and we also will be providing the slides afterwards. If you have any questions, go ahead and put them into the Q&A. And for those of you joining us on LinkedIn, go ahead and put them in the comment section, and I'll make sure to add them into the Zoom so that we can go ahead and address those at the end as well. At this time, I'm going to go ahead and hand it over. Stepan, take it away.
Yeah, thank you. Thank you, Melissa. It's awesome to be here. Me and Alex were in San Francisco. We just had a discussion. It's foggy, rainy, and cold now. So if you plan to go here, it's not the right week, that's for sure. Let me just share my screen, and Alex, help me just tell me if everything looks good and you can see my slides.
Yeah, everything looks good. Thank you everyone for joining.
Yeah, thanks, Alex. So we'll talk today about the fintech. So like fintech is an exciting industry. I would say like there are like multiple hot industries right now, right? Like it's all about the dev tools, security, infrastructure tools, but fintech is absolutely hot. You can see like the massive rounds of investments, like everybody's using different kind of services. It's multinational, so like there are a lot of startups in North America, Europe, Asia. So it's very exciting. And it's also very challenging. So like we have a lot of friends in the product security teams and security teams all over the place that work for the fintech companies, you know, like neobanks, banks, different kind of tech services, and so forth. And all of them are struggling. And there are a few challenges that are very specific to the fintech. So we'll talk about them. And also, obviously, we'll talk about like what to do about that. What works, what doesn't work, and what you can do and try. We'll try to keep it very practical, you know, like try to give you some solutions and maybe some kind of tools and materials you can read. Let's just start. Alex, do you want to add anything, by the way, before we go into it?
No, I'm good. Yeah, looking forward to showing you the new features and the console when it's my time.
Yeah, Alex, yeah, thank you. You will be super helpful to show all the demos, and everybody always appreciates to see the product in action. So let me start with this slide. It's actually about like what are the APIs? When we talk with a lot of people, they don't really understand like how often like the whole infrastructure of the company is based on the APIs. You know, like when you take a look at the traffic in the whole internet, 83% of all the web traffic would be our API calls. It's basically like it's overwhelming number, APIs everywhere. And this is the data from Akamai, by the way, because like it's the largest CDN in the world. They see a lot of data. And this is the data we have, like 83% of all the traffic are API calls. Gartner is also saying like something about the security, like what they're saying is 90% of applications will have more surface area for attack in the form of exposed APIs rather than user UI. So like it's really, really changing from the very basic apps, like more traditional apps, towards the attacks over the APIs or API-based apps. So it's really, really hard even to separate all those things. So APIs are here. We'll talk more about that, but just like I want to give you this overwhelming number. 83% of all the traffic in the internet are API calls nowadays. And obviously, there are a lot of attacks. Like it can be API specific attack, or it can be just like application specific attack, like not necessarily tied into some kind of like API flaw. But at the end of the day, it's just like APIs are becoming the #1 attack vector. And like we all know like a lot of examples of the data breaches recently are in the very large orgs, frankly. It's not something that is just typical for medium-sized companies. Like it's typical for everyone. It can be a small startup, medium-sized company, or a large org. It's just like the same pretty much everywhere. Let's talk about specifically fintech, right? A lot of people are thinking, hey, what is different about the fintech? Like, what are the attacks for the fintech like? What's different from e-commerce, for instance? Because e-commerce, obviously, it's also the very lucrative target for the bad guys, but fintech is interesting because like you have so many different kind of types of attacks, and it's also like any fintech company has a direct access to the funds of the customer. So this makes this are way, way more challenging for the security teams. And when we talk about the types of incidents, I would say like we typically talk about four of them. Like first one is data exfiltration. Pretty common, right? Like vulnerable APIs or apps, they can be exploited and the bad guys can get an access to the database of the users, different kind of PII, very bad thing to happen. Another thing is account takeover. So like you have a lot of those users, all of them have some kind of funds, and the fintech, like, I don't know, let's talk about the neobank where it can log in and just like transfer money from your bank account to someone else. So like if the attacker is able to get an access to the account of the user, technically this bad actor can execute different kind of transactions. So like account takeover is another type of the incidents, like very, very common for the fintech space. The third thing, fraudulent transactions, is just like different kind of business logic, and not even business logic flaws. You know, it can be basically any vulnerability can let the attacker to execute the transaction that is not supposed to be happening. So like this is what we see all the time, and this is pretty common specifically for the fintech space. And the fourth type is basically service disruption. You know, like all the fintech companies, obviously they have very high standards for the SLA, SLO. They need to be online all the time. And what the bad guys can do, they also can disrupt like the service by executing different kind of DDoS attacks, but frankly, it can be even some kind of vulnerability that can lead to the cooldown time. So those are the four incidents. When we will talk about the challenges, you will see that mostly all of those challenges are somehow tied into these potential incidents. And what's interesting is to see what people from the industry are saying, like there's this report from the YOL Technology Services, and the question that was asked like to the large group of people in the fintech space, mostly in Europe though, the question was, what is your greatest fear about what could happen if the data is compromised? And like you can see the numbers. So like half of the respondents actually are afraid that this will happen again. You know, like this is already happening. So there's no guarantee this will not happen again, and like we will be ready. So like that's it. This speaks to a lot of things actually. Our fines, legal compliance, sanctions, better reputation, and so forth. So like all of them. It's funny because like pretty much everybody is mentioning all those fears. It's like not the situation when somebody's afraid of one particular thing. Like in this industry, you really have a lot of fears, and you need to deal with this. Let's talk about the challenges. Like the structure of this conversation that we will try to use is to have different kind of challenges that we've been thinking about the industry. And what I want to have is like a very structured discussion. Hey, this is the challenge number one, challenge number two, challenge number three. And I will try to give you some insights about what we can do, what you can do with the open source tools, like what are the best practices. So let's try to do that way. And the challenge number one is APIs and application usage has exploded. It's just like we have a lot of apps and APIs. And these are the results from the Postman. So for all of you who are not using Postman, it's a great tool basically for the API developers. And what the guys are doing, they conduct this survey every year by talking with a lot of companies, small and large, about the usage of the APIs. And what's interesting is like the number of APIs overall is growing tremendously, but also what's interesting is the breakdown, because when we talk about the APIs, we talk about three things. First, public APIs, something that can be used by our mobile app or desktop app. Those are used by they exposed publicly. Everybody can use them. Another type of the APIs are partner APIs. They are supposed to be used by the partners, and they typically share with the partners. There's no guarantee that they only share with the partners, but they are supposed to be shared with the partners. And there's also private APIs, something that is not exposed. You're supposed to have it only internally. Like a good example here is just basically microservice. You know, there's a microservice. It is implemented as a form of API. It's not exposed, and it's supposed to be only used internally. And if you will see, the breakdown is this: 58 of the APIs are private APIs, 27 APIs are partner APIs, and 15% of them are public APIs. You know, something that is openly available all over the web. The number of the public APIs is growing year to year, same as the partner API. So like we will see a massive change, like the whole ecosystem here. But what's also interesting and what we see while talking with the companies is the zero trust initiative. So a lot of people actually start thinking, okay, I have all those APIs and they are not supposed to be exposed. However, I'm not sure what is happening inside my perimeter. I mean, like a perimeter is also a very complicated term nowadays, especially in the cloud environments. But basically the idea is that people start thinking, okay, those APIs are not necessarily exposed, but should I use the same security policies for them as if they would be exposed? This is an interesting trend, and we see this over the last 18 months a lot. A lot of people actually start protecting their internal APIs the same way as if they would be exposed outside. So APIs are used by pretty much everything. Like, it can be customer-facing apps, something on your phone, or like for mobile banking or trading, or cryptocurrency wallet, or whatever else. So our customer-facing apps are in the form of desktop apps or mobile apps. It is the partner APIs, some APIs that can be used only by your partners. It's very typical if you're in the fintech space that your users actually are other fintech companies. It's a pretty common thing. And obviously microservices-oriented infrastructures and architectures. So this is what I've just talked. Like a lot of companies have a lot of internal APIs that are not supposed to be exposed. Keeping track of everything is a huge challenge. If you talk with a large company, there is no chance there would be somebody who will be aware of all of the APIs they have and what kind of data those APIs expose. It's just like not possible at all. And as you can see, like you have hundreds of APIs and endpoints. Some of them can be managed. It means that they are managed and configured with the API management or a different kind of API gateway. Some of them are actually unmanaged. Those are spun up by the developers, and they became exposed, and they are not even managed by the API management system. So this makes this inventory even more harder. And funny enough, Gartner is saying that by 2025, less than half of the APIs actually will be managed. And this is a big thing. So you have all this issue with the zombie APIs, those APIs that are deprecated already, but for some reason they're still exposed and are usually vulnerable. Those are the legacy APIs, and so forth. Keeping track of the APIs is hard. And that's why this task of API inventory and API discovery is so important. And it's hard to do. Like, first of all, you can introduce different kind of hygiene within your developers so that everybody is keeping track of the inventory in the internal Confluence and so forth. But we all know, like, it's really hard to follow this process. So there would be inevitably something that is exposed and nobody's aware of. So what you can do, you can try different kind of tools. Obviously, you can try WallArm. We'll talk about later. But also, you have an option to use some open source solutions. Like we usually talk about the API Clarity. This is the tool that primarily works for the Kubernetes environments, but it gives you some kind of visibility of what kind of APIs you have. And the idea, as with WallArm, is to reconstruct the APIs based on the traffic, based on their actual usage. This is the open source tools. Obviously, there's some limitations there. But if you want to try something, if you have Kubernetes already, this is a good start to try it out. And during the demo of WallArm, we'll show what we can do on the API discovery as well. Switching to the next challenge: high velocity of innovation and increased complexity of APIs. So it's not only the number of APIs, which is a problem. The problem is also the complexity of APIs. So when we talk with the fintech companies, all of them are pretty innovative, or a lot of them raised massive rounds of investments. They have an exploding database, and they have pretty aggressive plans for the product and dev teams. So we see that there is a high velocity of engineering. People are trying to use different kind of cutting edge technology, frameworks, protocols, and so forth. It just adds more security issues, inevitably. Yes, you run faster, but you're still you're somehow sacrificing the security, and you need to manage this, right? So this is a process to manage, and this is hard to do. So one of the challenges here is a different kind of new stack. GraphQL wasn't really a thing 5 years ago. By 2025, Gartner is saying that 50% of the enterprises, half of the enterprises, will actually use GraphQL in production. gRPC, a new protocol that was invented by Google, we didn't see it a lot 3 years ago. Nowadays, we have a few customers that are have everything based on gRPC. They don't have anything else at all. Our WebSockets, HTTP, the different kind of infrastructure-oriented things like Kubernetes, multi-cloud. it's a very common thing to have this cutting edge tag in the fintech companies. And the consequences of it is that it creates new attack vectors. Like managing Kubernetes is hard, protecting Kubernetes is hard. Speaking of the applications and APIs, like we've been trying to follow everything from the OWASP top 10 for years. Now we also have this API security OWASP top 10, which covers specifically attacks for the APIs. And you already have some kind of security tool in place, different kind of WAFs and different tests and SASTs for testing. So surprise, surprise, some of those tools are not really working with the APIs, or they claim to work, but they're not really effective against that. So another thing is that your security team is not always equipped to work with this new solutions, not only from the tooling perspective, but also from the best practices. Like when we've been working, like in all of us, been working with the REST and SOAP APIs for years. Now we have this, like all of a sudden have GraphQL APIs, and there's new threats, new attack vectors, and you need to deal with this. You need to catch up, which actually adds a lot of more work to the product security teams. It is hard. So the important thing here is like a lot of people don't realize, and they also believe vendors, that the solutions and existing tooling they have is as effective for the APIs as it has been for like general applications. So like one of the recommendations we usually have is like to check if your existing solution is really ready for the API stack. Is it ready to be used like with all the new requirements, like from DevOps and infrastructure as a code approach, like to use as part of CI/CD? That is not the case, unfortunately, usually. And yes, like if you have all this new tech stack, you just need to have something that can protect your workloads in production. And I'm not even talking about the detection here. I'm talking about both detection and mitigation, so that you can protect your APIs and apps, even if you have this high velocity of innovation. If you have like releases two times a week or maybe every day, it's hard. It is really, really hard. And obviously you need to introduce some kind of tooling and automation into your development pipelines. So we'll talk more about that while showing the demo of WallArm. But as always, you have an option. You can go and use some kind of open source tools. And these are some of the solutions they can try to use. Or for instance, this tool, schematicist, it actually supports GraphQL, which is awesome. Like if you're already using GraphQL, you can try and use it. Or Wrestler, this is the product from the Microsoft Research, more kind of like very, very dev-oriented tool, so to say. Not always easy to use by the security teams, but and it's also kind of more research project. But actually, the idea here is that you actually can upload the Swagger, and the tooling will execute the fuzz, and it will try to identify different kind of issues. And obviously, like you can try and incorporate those things into your development pipeline, so that you have this automated security testing. It's not hard, it's not easy. No, it's not. Like as well, like as always with the open source tools, but at least we have all those options. And I just think it can be helpful to bring some of those names up here so they can play around. One of the tools that I want to mention is Go Test Web. This is the tool we created for ourselves. And this is a very interesting tool because it can try and send a few checks against your existing APIs, even if they are protected with some kind of web or API security product. And the goal here is to show you what are the attacks you are not, like which of the attacks can actually still hit your applications. Even though you have some kind of security solutions and tooling in place, we will be able to show you where we can bypass it, like what are the threats are not covered, and so forth. So you will have, in many cases, you will be a lot surprised. And this is, by the way, also the way how you can check if your security solution is actually helping you to protect against different kind of threats. Switching over to the next thing, so we're challenge number 3, are highly motivated attackers, and as a result of it, highly sophisticated attacks. So when we talk about the fintech, it's interesting because usually, like companies from the fintech and financial services, they have the attackers can get the access to the user's funds or crypto stored on multiple accounts. So it's actually a very short path from the attack, like for the attacker, from some kind of exploit or a successful exploitation of the attack to the cache. Like it's not a thing in many other industries. It is a thing in the finance industry, and especially in crypto, when you can get an access and you can just like transfer it somewhere, and like there's no way how we can revert this operation. So we see just a lot of very motivated attackers that are ready to conduct a very sophisticated attacks, by 0 days in different kind of APIs and applications. They can try and be very innovative in using some of the existing exploits and so forth. So you just need to be prepared for that. It's a big challenge. So just to give you an example, like all of us remember what was this December, like last December, Log4Shell, right? This kind of vulnerability that everybody was talking about. What's interesting for us was that the attackers very quickly, it's just like within the 12 hours, they started to use and try to apply this different kind of Log4Shell exploits, not only against very typical endpoints, like kind of any headers of requests and so forth. No, they tried to exploit and to use the exploit in the gRPC against the gRPC-based APIs and so forth. So they try to be innovative. They know, okay, this cryptocurrency company, they are relying a lot on the gRPC. So why not to try to use this exploit in the gRPC and so forth. Or this neobank is using WebSockets, which is a pretty common thing. So they will try to use this exploits via the WebSockets and so forth. So we see this all the time, and this is another reason why you should be very careful in validating what your existing tooling can and cannot do, because like in many cases, you can think that you have proper protection, but in reality, it's not there. And speaking about the APIs, what we try to do is, and to show is that you really should have, and I'm talking here about the protection of the workloads that are in production. You really need to think about like multiple layers, so to say. A lot of you probably already have API management or API gateway, and this is great. Actually, some fundamental pieces of API security you can get just by using the API management or API gateway. I'm still talking about the access control. I'm talking about the authentication. I'm talking about basic rate limiting. This is what you can do by using, let's say, Kong, like open source API gateway, or you may use Google APG or MuleSoft. All of them will provide these capabilities like out of the box, which is great. You should do that. Like this is the fundamental pieces. Then there is WAAP, those kind of products that are formerly known as the WAF. And they can protect your apps and APIs sometimes against OWASP top 10. For the APIs, unfortunately, most of the web vendors only support what they call positive security model. You upload the API specs, we will make sure that the requests are matched with this API spec. Pretty basic thing to do, but unfortunately, most of the well-known web vendors only provide this, and this is like at least not the maximum protection you can get. So like be careful about that. But WEF can also help you to block different kind of malicious sources, Tor, different kind of countries, and so forth. But then there's another layer, like which we call API security, kind of advanced API security. This is where you can get features and capabilities like API discovery to have a full inventory of everything. You can get a protection for pretty much any APIs without providing any specs. Like the tag detection works in a way that it just works right from the very first minute. You don't need to configure it, upload anything, tune anything. So in case of WallArm, for instance, we can inspect all of the APIs that are hitting your API calls that are hitting your API backends, and basically provide protection against different kind of stuff. API security solution can provide a protection against account takeover, different kind of API abuse, or L7, DDoS, and so forth. So that's why we've been thinking about these layers. And you absolutely need to have layer number one at least. Like it's really hard to manage and like provide security for APIs without API gateway, but then you need to have like multiple layers on top of it. And this is the way to go. Let me switch to the next one. So the next challenge is the compliance. And as you all know, there's probably no other industry that is more regulated than finance services, and fintech. Maybe healthcare. Yeah, healthcare is another one, but we all need to deal with a lot of compliance, and there are a lot of them, right? Some of them are European, some of them more specific to North America. There are some for the Asia. In many cases, you need to know where you are exposing PII data, like where the sensitive data is accessible. This is specifically talking about the APIs. And once again, this is where API inventory and API discovery can help you just to identify all of those places to streamline your compliance. Some of the compliances actually ask you specifically to use different kind of WAF and API security tools. Like PCI DSS has this very old but still actual 6.6 requirement to use a web application firewall for the publicly exposed assets. So compliance is the challenge, and with everything else I already mentioned, like dealing with compliance, meeting all the compliance requirements is getting more and more complicated if you're in the fintech space. Some of you will say, hey, there's open banking kind of initiatives. Are they helping? Yes, they do, from one perspective. From other things, standard doesn't necessarily mean that you will be secure by just following these standards, because at the end of the day, business logic is on your side, and you can introduce the very same vulnerabilities as anywhere else. So even having a standard doesn't give you a guarantee that you are not introducing vulnerabilities and you are not vulnerable. So this is just the fact. Compliance is not fun, but once again, having the tooling in place, like API discovery, that can show you what are the APIs you need to take care of, like, and provide it to the compliance team. What are the APIs that can be exposing sensitive data? Like, once again, it's very, very helpful to meet the compliance requirement. And it's hard to live without it, frankly, especially if you're working for the larger orgs. Switching over to the challenge number 5 is where I want to touch base the dependency on the third-party providers. Like for the fintech, I unfortunately didn't find a good picture, but in the fintech, it's all about the partners, right? There's like partner number 1, which is doing processing. The partner number 2 is providing some kind of KYC. The partner number 3 is doing something else. And it's all connected, like by working in the finance service, you really rely a lot on the third-party partners, and you're using those partners over the API. So you can have your own public APIs, you can have some internal APIs. In a lot of cases, your internal apps and APIs, they're actually using the partner APIs. What's interesting is that in a lot of cases, you actually trust, you trust what you're getting from your partners. It's good if you have some kind of validation of what you're getting, but believe me, it's not always the case. And many companies and many developers, they're thinking, okay, this is a big company. I'm using their APIs. This is their responsibility to take care about security. I just blindly trust them. And you just get all the data from the partners, and like, you don't even know what's in there, and you consume it and start using internally. So like, this is a risk, which is at the moment, I wouldn't necessarily say that everybody is talking about that. But over the last 12 months, we had at least a few discussions with the larger orgs that were very, very worried about that, because they didn't validate any data coming from the partners. So this is a challenge. If you have a lot of reliance on the third-party APIs, you need to check what is coming from those partner APIs, especially in the fintech space, because at the end of the day, you use it a lot. You use those APIs a lot, and often there's no validation, and you just like rely and trust with those partners. And those partners, they're also companies, they're also people like we, and they're human like we, and they can be compromised. And that makes this thing challenging. Like, you need to have a control and the way how we can monitor and inspect those in the communication. So this is a challenge. And by the way, I will have a slide later for that. One of the solutions that can be helpful for that is to use our positive security model, actually, because usually communication with the partners, it's not changing much. This is not where you can you need to configure it all the time. You can enforce the specs and you don't really need to buy anything. So one of the tools that we've released is called API Firewall. It's an open source tool that can actually provide this positive security model for you. So this is where you can use it just free of charge. Switching to the gear to the next challenge, legacy systems. Yes, our fintech, especially financial services, have a lot of legacy. So this is how it is. And even if you have a very fancy, very cutting-edge product, you still need to deal with the legacy, and that introduces more challenges, right? Like it's always there's the desire to get rid of everything old, like rebuild from scratch, but this is not how the finance work. So you just need to deal with the legacy stuff, and obviously legacy stuff can be vulnerable. Legacy stuff is really hard to fix and patch, and this is an issue. And I'm not even talking about the APIs here. It can be APIs, but also different kind of business apps and so forth. Some of them can be internal and deployed on-prem. Some of them can be hosted somewhere else. But we need to deal with these legacy systems. And ideally, while working and choosing the product to provide the protection for your apps and APIs, ideally, you'd better have something for everything. And you have options. Either you're using multiple products for all those things, or you try to find one unified product that can actually help you across everything, like internal APIs, exposed APIs, legacy apps, and so forth. Just don't forget about this legacy stuff, because this can be a target, and this is usually a target, frankly. Challenge number 7, availability. So obviously, if you're a bank, if you're a payment system, you don't have an option to go downtown, to have a downtime. You just need to be online, and if you have a massive customer base, which is not a rare thing for the fintech companies nowadays, for the trading and so forth, and the trading by itself has a lot of requirements like zero latency, high uptime. If your customers cannot execute some orders quickly enough, if there's a latency, that's a very, very bad situation, and nobody will tolerate it. So while choosing security products, you need to think about how to make sure that they actually can meet my requirements for the SLAs. And would those security products be an issue for the way how my infrastructure is managed? Because the latest thing you want to do is to become, as a security org, the latest thing you want to do is to be unfriendly with the infrastructure team and the DevOps folks. So that's why we always talk a lot about how important it is to find security solutions that can be a good fit for your infrastructure, multi-cloud infrastructure, Kubernetes infrastructure, the security products that can be actually managed in a way how your other infrastructure is managed for the infrastructure as a code approach. Something that the DevOps people will take a look and say, hey, yeah, we'll like it. We just want to use it. And unfortunately, especially talking about the old security vendors, it's not often the case. It's not that every security product in the world is cloud native. It's just not there. And another thing I just want to mention is here, what can be an issue for your availability is different kind of API abuse, different kind of denial of service attacks, and so forth. So while having a security product or maybe even an API gateway, you need to make sure that you actually can run and provide the advanced rate limiting, and better to have a more robust protection about that. So one of the things that we provide, and API rate limiting, is what you can do with the API gateway, even the open source. But if you need to look for something else, and they have this rate limiting across multiple clusters in different locations, if you want to take into consideration some very specific rules about the request parameter or anything else, you need to use something more sophisticated. So one of the things, by the way, that WallArm can provide is this, what we call triggers or advanced rate limiting, where you can set up the thresholds and it can be very granular in what you want to rate limit, breaking down specifically to the request parameters and etc. Which might be really, really, really helpful for you in your environment. So those were the challenges. I wouldn't necessarily say that those are all the challenges in the fintech. So you probably have a lot of others. And by the way, we're happy to learn more about the challenges from you. We will add them for the next presentation. But now let me just talk a little bit about what WallArm can provide, because in most cases, when we build in a product and we've been kind of maniacally focused on the APIs and API security for the last 7 years. So we've been adding a lot of cool stuff specifically to protect APIs, and all the time we're thinking about challenges like, hey, what kind of challenge is to protect the workloads that are running the AWS and specifically running in the finance industry. And like we've been adding features like deep request inspection and so forth. So let me give you a very quick summary, and then we'll switch to demo to talk more about the product. So typically what we provide is discover, protect, respond, and test pieces. So discover is all about how to identify the attack surface, like what kind of APIs you have, what are the API endpoints, what are the parameters there, where the sensitive data can be exposed. So it's all about how to use your usage of your APIs to give you the picture, the map of all the APIs you have. And this can help you to understand your attack surface in the form of the APIs and keep tracking changes, like what is changing there. Remember, I was telling you that nobody in the big company knows what are the APIs they have, what are the APIs exposed, why this V1 version of the API is still exposed, if it's deprecated, and so forth. So this is the answer to your questions, because this is what it can use and very, very quickly get the full picture of what is there, and even download the specs and even maybe compare with the specs from your developers to find the difference. And there's also always a difference. Like most of the projects that we're having, there are a lot of surprises for the companies because they found the APIs nobody was aware about. One of the things here is that we also have this module that can identify the assets that are exposed. They are not necessarily APIs, but we also can find all the domains, subdomains, and everything. Just give the domain of your company and we will find everything the bad guys can find. So it's kind of discovery from both parts based on the traffic, but also based on the outside scanning. Protection. This is the bread and butter for WallArm, because this is what we do for a long time and do it very, very well. So if you need to protect apps, you need to protect APIs. If you need to protect GraphQL, gRPC, REST, whatever APIs you're using, we provide what we call API threat prevention. So like we will inspect all the API calls, we'll find malicious requests in there, and we'll be providing the capability to mitigate those attacks in real time. So it's both detection and mitigation all in one product. So it technically can use it for the legacy apps, for the modern applications, for your APIs, internal APIs, exposed APIs, and so forth. And it's important that you don't need to tune it, you don't need to upload the specs, and so forth. Respond is all about the incident response, because you will have the attacks, and like as well as everybody else. You need to streamline your incident response procedures. So we will give you full visibility of all the API attack chains, what the bad guys were trying to do, which of those malicious requests are related to each other. We will reduce the noise as much as we can, but we also can provide you with a different kind of capabilities to automate your incident response by integrating it to your existing workflows, but also providing different kind of testing automatically. So if you're having this attack, we can say, hey, we actually validated this attack. We know that this API is not vulnerable to this type of attack, so don't worry, this kind of stuff. So response part is very important. And the test part is all about testing. So like we can identify all the assets that are exposed, check it for different kind of issues, and show you that we can rerun the attacks against some of the API endpoints and see if they're vulnerable to different kind of attacks, and so forth. So those are the key things. But the question we usually have is the deployment. So Alex, by the way, do you want to talk about the deployment? Because this is the important thing. Like people are saying, hey, do all that kind of stuff, but actually how I can deploy it.
Yeah, of course. So one of the deployments methods we can use is pretty much could be installed everywhere. Think about WallArm as a proxy, an intelligent proxy, be able to do the analysis of every single request incoming into your system to your APIs. One of the deployment methods that is common in cloud native applications using the modern protocols that Stefan mentioned is actually Kubernetes. So it could be a Kubernetes ingress controller, could be also installed as a pod, could be in a classic environments as an Nginx, Envoy if you have it, could be installed as part of your API gateways, could be also cloud, and it's also cloud agnostic. So it could be running your workloads in Ajiki, EKS, IKS. Again, is the deployment is a Docker container or a Kubernetes ingress controller. We also support serverless applications where you can add actually in front of it or as a deployment in a Docker container.
Yeah, thank you. A lot of options, and pretty much any infrastructure, for every infrastructure, we can find a way how we can deploy it. The important thing is that all the traffic is analyzed locally. So we're inside your infrastructure, there's a requirement for latency. So like all the traffic is analyzed with the so-called WallArm nodes that are deployed in your infrastructure. And it's milliseconds of added latency. That's why it's important to keep everything on-prem. And at the very same time, we provide a powerful cloud solution that have all the data about the attacks and incidents and your infrastructure, API inventory, which is sitting in the cloud. So we call this hybrid approach, where the traffic is analyzed locally, but you have all the analytics, all the BI, all the data about the attacks and the automations that are working in the cloud. Alex will show the demo of it. I think we talked a lot about the API discovery already, so probably just show the demo for the sake of time. But one of the important thing I want to emphasize is the deep API request inspection. So this is something that we invented. This is somewhere where we invented a lot of time. Remember, I was telling that a lot of web providers, they are asking you to upload the API specs. And after having the API specs, they can match every request with the specification. And this is how they provide the positive security model. So providing the specs is hard. If you have thousands of APIs, if they are updated from time to time, it's hard to configure it. This is not what your security team will like. This is not what your developer team will like to do. So the approach WallArm is taking is by automated analysis of the request. So if we see that there is a request for the GraphQL endpoint, we will automatically parse it, analyze the structure of it. We don't need any schema. If there is a complicated structure, let's say some of the parameters encoded into the base 64, WallArm node will automatically seize that, okay, this is a JSON, there is something encoded in base 64, and it automatically unwrap it. It's full, very deep inspection. The goal of it is actually have a representation of the key value parameters of any API call or any HTTP request actually, and apply attack detection to everything that is possible. And this is the way how we can identify attacks on the very granular level, by applying the multiple attack detection techniques to pretty much any and every part of the API call. I think that it's a good time actually to switch to the demo, so I'm handing it to you, Alex.
Okay, perfect. Thank you for that. If you let me share here. Okay, so this is the console. So whenever you start a trial or you are using our product, you have access to the console. Here's where you manage your security requirements using WallArm. The first thing I want to talk about the new feature, API discovery. The way it works is, as Stefan described, we're in the line of fire. So it's acting as a proxy. So from your user connections, as your users are accessing your APIs, naturally accessing all your endpoints, consuming your services, WallArm is able to detect and reconstruct the schema directly from those user connections. There is no need for you to upload the schema directly from the wire from those user connections. WallArm is able to identify all the endpoints. If it's a post request and you have all the fields discovered, they will tell you if it's found in the header, body, or any other parameter. If you see asterisk, means that WallArm has been detected 99% of the time, this being always present in the request. So WallArm is going to consider this as a required field, as you can see in a Swagger specification. So if you look at a GET request, you will see also the query. So essentially, WallArm is building everything from your user connections. So there is no need for you to upload a schema. And one of the use cases for this is to identify how your users are consuming your APIs. This represents real use traffic. You have your specification as part of your CI/CD pipeline you released, and this represents the real use traffic. So if you see, for example, version 2 that has been deprecated and is not being used anymore because you're not maintaining the API and you don't know if there's security or vulnerabilities attached to it, you can actually perform a rule, and WallArm will auto-populate this rule with a specific content, and you're able to perform these actions. One of the examples I want to show you is to set the traffic filtration mode to blocking, and at that point, that input cannot be used anymore because you're not maintaining, has been deprecated, it becomes a shadow API. The other thing you can do is identify, different endpoints that is going to be, that has been deprecated or not, they shouldn't be available anymore. If you don't have any documentation, you can click in the download button on top right, and you can actually download the schema, the Swagger schema in a JSON format, and you can actually take it, copy paste in any Swagger editor, and recreate the schema and document your APIs if you don't have any documentation. Again, this is coming directly from the user connections. Another thing is important is the fact where you see this target icon. If I click here and I go into events, I'm able to see all the attacks related to that specific endpoint. Now here, if I go into something that has been blocked and protected by WallArm, 403, for example, I want to show you an event that actually is related to that specific API. And if I go, for example, a remote code execution, you can see the attack directly to that API demo. Now, this is something WallArm able to support the other protocols, for example, gRPC. So if it's over a protobuf, it will be supported. If it's GraphQL, if it's REST, if it's SOAP, you can see the payload that triggered this attack, the source IP, and the blocking code. WallArm is inspecting the URI, header, and the body of the attack. This is important because every single one could be a potential attack vector. You can see here how the attack was embedded into this field. And this, if you're not have any syntax validation, and you can actually, your backend can make sense of this data, could be actually affect your application and damage your backend. So as you can see here, WallArm is able to reconstruct the schema, again, from all the protocols that is being supported. So this happens in real time for every single request incoming into the system is being filtered and analyzed by WallArm. One of the things I want to mention is the rules. WallArm has an intelligent backend. For every request coming in, it's going to create a specific profile of your application. So the idea of WallArm is low TCO. We want WallArm to take care, the efforts on the security maintenance. This is different from versioning and having rules 1 to 10 in a firewall. The rules are generated automatically by the backend. There's an intelligent backend using statistical methods, algorithms, and pieces of AI, analyzing the profile of your application. You have also the opportunity to add also manual rules. Let's say, for example, you have a new app in staging that you want to just onboard as part of your security protection. So what you can do is set this specific application and set the filtering mode into monitoring for 7 days while you wait for the profile to be created. Once this happens in 7 days, the false positives are 0 or close to 0. Then at that point, you can remove this rule and onboard this application into blocking mode and get the protection. So every time there's a request that's being protected, blocked by WallArm, the application will never see it. It will never be processed. So the load of that processing just happens in filtering modes provided by WallArm. One of the things I wanted to mention, if we still have some time, is the triggers. This is one of the slides that Stefan showed you. So one of the things you can actually do is create a trigger for a brute force attack. you have a specific endpoint you want to protect. The option is to rate limit. The other option is to do a L7 based on a specific URI. So it could be api1.login.com. And what you can do is specify also other parameters as part of the header. And then you can add a reaction. This reaction could be marked as a brute force. And also add, for example, blacklist this IP for certain periods of time. So as soon as the threshold has been exceeded, in this case, it's 30 requests over the last 30 seconds, you can actually blacklist the IP and stop the processing of the brute force to that specific API endpoint. Perfect. Some other things I'd like to show you is the scanner capabilities. As you know, the first thing an attacker is going to do is discover what you have out there, all your API endpoints, all your web applications. So WallArm is going to discover using DNS technology, everything you have available in your DNS rec where SSL certificate is able to map out all your domains as subdomains. So how WallArm is going to use this information to protect your applications is in the vulnerability sections. There are 3 operations that is going to happen here. One of them is active threat verification. As you can see here, has been detected log4j. So the way it works is if I go into our documentation, WallArm is going to take the initial attack. This is coming from the attacker. You can see the base URI and you can see the token has been used. And this attack could be anything. Could be a cross-site scripting, could be remote code execution in any of the programs, be protobuf, WebSocket, GraphQL, could be any format. So that attack is being detected by the system. So WallArm is going to do and take that initial intelligence from the attacker and enhance the request by adding variations over between 150 variations and check against your applications if there's any vulnerability. So you can check if your application is vulnerable to this specific attack. If you don't want to send this to production, we have the ability also to send it to staging. And you will see here in this case, remote code execution has been detected. The other one is based on those endpoints I just mentioned, you have something called vulnerability scanner, where you can also detect application level specific vulnerabilities, or for example, OpenSSL libraries that have been encountered. This is just running a CVE and CWE database against those endpoints. You can see here how you can reproduce them. The last one is passive detection. Basically, we are detecting and listening to the responses back to your end users. What are you leaking back to your users? Is that the password database, SQL errors that should remain local to your backend and not be released to your users because it could be used as a potential attack vector. And finally, really quick, our main dashboard is here you can see a graph of all incoming requests into the system, the attacks in orange, and you can see the incidents being confirmed as part of your environment. You can organize here your applications based on IDs. Here I organize everything just based on the different type of APIs, but could be your dev environment. You can get metrics in terms of hits, trends, of attacks. We show you the top attacks encountered per endpoint discovered, and also the source of the attack by country code and data center. Well, I hope this was useful. Thank you so much for your time. Maybe we can open to some questions. I know there were a couple of them on the chat.
Yeah. Let me show a few slides here before. I know that we're running out of time, but thanks for awesome demo, Alex. Just a few things to mention. We have this project that I've already mentioned before, open source API firewall. So that might be a good thing to start if you're looking for some simple tool to provide this positive security model. So like it's on GitHub, just go there and download it. Another thing that I really encourage everybody to do is download our API security checklist. This is the document where we try to organize like all the risks that can be relevant to your APIs. It's not specifically for the fintech industry, like it's written like overall for everybody, but we basically say, hey, there's a risk, improper API asset management. This is what you need to do. Or API abuse, lack of resources, and rate limiting. This is what you need to do. Or injections. This is what you can do. Just go to there for WallArm and download it. It's very practical, something that you can use right away in your environment. And lately, I know we did have a lot of time for demo, and it's not even possible to show all the use case and how you can use it in production. So I'm encouraging you to just go to my@wallarm.com and click the create an account and basically create your account for API security. And happy to talk with you and just show more stuff. I don't know, like, if we do have time for questions, but I see that you answered, Alex, already some of them, right? One of the questions is about the coverage for the NFT API test. So I'm not sure what specifically these are. This NFT API, but if it's an API, it is API based on some kind of REST, so gRPC, GraphQL, and so forth. We will be able to inspect it and provide the protection there. A lot of people are asking about the copy of the slides and presentation, so it will be available. Melissa, where it will be available, by the way?
Hi, so just everybody who is asking about this. So the recording will be available later. It is on our YouTube channel, which is also accessible via the webinar section under resources on our website. Anybody who's on the Zoom, you will get a link directly from me tomorrow that has a link to both the slides and the recording. For those of you joining us from the LinkedIn stream, I will put a comment in there. You can always send a request in to get that if you hadn't already signed up on the Zoom link. So we'll make sure we try and get everybody covered there.
Yeah, and I think it's a good time actually to wrap up. Since we're running out of time, maybe one more question. We have a lot of them. Talking to prospects here. Yeah, there is a lot of feedback, a lot of questions. Let me just find something we can answer quickly. But what I'm doing, guys, I'm also copy pasting some of the questions so we can follow up with you. So the question is, what kind of data does it collect to be able to understand what is the correct request for my deployed API? So for a lot of cases, we don't really even need to understand what is your API, even though we can get it. It's all metadata. We don't collect the examples of your requests or responses. And the way the attack detection works is based on the, we actually have a few attack detection techniques. One of them is grammar-based. It's open source, so you can go to the GitHub of WallArm and find the library. It's called lib detection. It's all about the grammar-based analysis. There are a few other questions.
The other question is what kind of data we collect? Do you want to address that one?
Yeah, it's only metadata. So like typically we have what we call privacy FAQ document. So which may give you answers on like what kind of data is shared between WallArm nodes and WallArm cloud. But typically there are two things. Data about the malicious requests, because we want to show them in the WallArm console that you can inspect and automate your incident response. And secondly, we share different kind of statistics. So technically, we calculate 200 distribution functions for every request parameter. And this is the data we can use actually to understand like what is the structure of API and so forth. But happy to share more white papers on that.
Also, something I like to do is share too. We are a SOC 2 compliant company. Just if that helps for you guys.
Yeah, absolutely. Okay, that was an awesome discussion. Thank you so much, Alex. And thank you so much, Melissa.
Problem. Thank you so much.
Thanks everyone for joining us, and we'll see you at the next webinar.
Thank you.